proceed. So, like I said, it's probably going to take 2 days to go through this lesson. We got a lot to go through, especially since today is a flex day. So, let's go ahead and begin. So the first thing I want to talk to you guys about is the domain and range. Not the range, just the domain of log functions. The domain of log functions. All right. So, bonus point time. Raise your hand now. What is domain? Yes, sir. All the possible values of x. All the possible values of x. Now, for some functions, you could plug anything in, like a linear equation. There's no reason why you can't plug any number you want to into a linear function. But other functions have limitations. We talked about rational expressions. You don't need to write this, but remember these? Like you can't plug anything in that will make the bottom equal 0, right? So some functions have limitations as to what you're actually allowed to plug in. And logarithms are like that too. Back on our, I don't know what it was, maybe our first day in talking about logs, we talked about this. Like if you had log base 0, or if you had log base any negative number, both of those things don't exist. There is no solution for those things. Okay? You could try typing it into your, DNE means does not exist, I'm sorry. Or undefined, you could say that too. Now, and we all, on your homework, I had you guys kind of explore the topic as to why that would be. You know, for instance, for a negative number, like let's say I had log base 2 of -8, right? Well, if you tried to solve that by hand, you're going to run into a problem. No matter what power you raise the number 2 to, you're never going to get a negative. I mean, how many times can you multiply 2 by itself to get a negative? That's impossible, right? Same thing with 0. If I had the 0 here, how many times can you multiply 2 by itself to get 0? Well, that's impossible. That doesn't even make sense. So, for logarithms, you can't have the argument be 0 or negative. So, here's the part that I would like you guys to write. For any log function, I'm going to do this. It's a little bit weird. This part that's in parentheses is what we're going to call the argument, right? I've been calling it that for the past few days. But for any log function, the argument has to be greater than 0. It can't be equal to 0. It's got to be greater than 0, right? So in other words, it's got to be a positive number. Now, I don't want you guys to get that mixed up with me saying this, because this is a different statement. What did I say has to be greater than 0? The argument. Did I say x has to be greater than 0? No. I didn't, right? Those are different things. Sometimes, if your argument really is just x, well then they're the same thing. But most of the time they're not. So, the domain of your log functions, the possible values of x, is restricted by the fact that your argument has to be greater than 0. Okay? So, let's go ahead and take a look at some examples of that. On your homework, it's going to say, state the domain. Okay? In other words, they want you to state what are the possible values of x. So, example 1, here you go. Let's put equals y. Okay, so for this logarithm, the argument has to be greater than 0. What's my argument in this problem? That's right, it's 5x minus 2. So 5x minus 2 always has to be positive. It's got to be greater than 0, right? So now the problem is asking us to state the domain. So they don't really, this is how we start, but we need to figure out, so what is x allowed to be? So all we have to do is solve this, right? If I solve this, that will tell me what x is allowed to be. And so here's my answer. X can be anything greater than 2/5. Anything less than that, that's going to make your argument come out to be a negative number or 0, and that's not allowed to exist for a log function. So that's what we mean by find the domain. Pretty straightforward, not too bad actually. So when you're asked to find the domain, all you do is you take the argument, set it equal to 0, and solve. Okay? So why are we talking about that? Well, the reason we're talking about that is because every problem on your homework is going to say state the domain. But why do they want you to state the domain? What our main objective for today is solving log equations, right? So we're going to be finding values for x. We're going to be solving for x, right? It's possible that you can get an answer for x, even if you followed all the steps correctly. It's possible that you can get an answer for x that is not part of the domain. And so those are what we call extraneous solutions, and you would have to throw them out and not use them. So we've written this definition before, but we'll write it again because it's relevant again. It doesn't happen often. Extraneous solutions. I've also heard them called excluded values. It just basically means something your function's not allowed to equal, or something your x value is not allowed to equal. So I'm being kind of wordy there, but there it is. So when you're solving for x, if you get an answer that's not in the domain, it's what we call an extraneous solution, and we're not going to include it as part of our answer set. Okay? We would say that's not the answer. Okay, so I think what we'll do now is we'll kind of take the two ideas that we just talked about and put them together to solve a problem here. Let's see. We'll call this example 2. We're going to do a couple things here. We're going to state the domain. And then we're going to solve the equation. Okay, two things there. State the domain and solve the equation. Okay, so here we go. Log base 2 of negative x minus 10 is equal to log base 2 of x. Great. So, first of all, I want to point out that we're going to solve a lot of different types of log equations, and this is only one type, and this is the easiest type. So this is one I like to start off with. The reason this one's easy is because we have a log on both sides, and the reason that makes things easy is because when you have an equation, whatever you do to one side, do to the other is safe, right? So here's how you're going to solve it if you have the log on both sides. All you have to do is, oops, I did not want to do that. All you have to do is just cancel the log off both sides. You're good. Just drop it. You don't need it, right? If you take the log off one side, you can take the log off the other, and those statements should still be equal, right? So that's pretty easy. I guess I don't really need the parentheses anymore. Let me erase those really quick. Okay. So at this point, let's go ahead and solve. So I'm going to add x to both sides. All right, just solve them for x, and then we're going to divide by 2. And so I get x equals, what is it? -5. Okay. I didn't do one of the parts of our question, though, right? I just did part B here. I solved for x. But the other part is we need to state the domain. So let's go ahead and state the domain here. So how do you find the domain? You take the argument, and you make it greater than 0, right? Oh, do you guys remember what special thing happens when you divide by a negative? The little inequality flips around. You might want to put a star next to that. If you ever divide by a negative, flip the inequality. Okay, so this means that x has to be less than a -5, right? Oh, did I make it? Oh, I did my division wrong. What's it supposed to be? Just 10. My bad. Good catch. Thank you, Mel.
Isn't it going to be -10?
Okay. Yeah, it'll be -10. Hold right. All right. So there's that. That's the domain restriction for this side. But let's do the domain restriction for this side also, because I didn't do the other side. What's the kind of running out of space here, so I'm gonna have to erase. What's the argument for the other log there? I heard someone whisper it. We did the first one. What's the first log had an argument of -x minus 10 is greater than 0. What's the argument of the log right here? It's x, right? So when you have more than one log, you have to look at both. They both matter. So we also need to do the domain restriction there. So here we go. So the argument has to be greater than 0. Is that what it says? Okay.
So the domain always has to be greater than 0?
No. Oh, no. X can be a lot of different things. The argument always has to be greater than 0. That affects what the domain will be. So in this case, x is greater than 0. So in this case, yes, because the argument is x. Okay, now let me ask you guys a question. Does this answer fit that criteria? Is it less than -10 or greater than 0? No.
What? Less than 0 greater than 10?
Is -5 greater than 0? No. Is -5 less than -10? Then am I allowed to use that answer? No. There's actually no solution. What the heck, Mr. Bailey, is going on here? Yeah. Sure. All right. Oh, good. I'm glad to hear that. That's always helpful. Uh-huh. Yeah, you can. So, but here's the thing. On your homework, they're going to want you to state the domain. But I think Amber made a really good point. Okay? So I want to revisit what she just said. Look. Here's my original problem, right? What was the base again? I don't remember. 2? All right. If you plug a -5 in here, or here, let's see what happens. Is that allowed? No. You can also check this one. If you plug a -5 in here, it would become a +5, take away 10, which is also -5. And that's why they came out equal that way, right? Because they both have the same expression. But is that allowed? No. You can't have a negative in there. Okay? So now your homework wants you to state the domain, so I'd say just go ahead and do that. But really what I do when I'm solving these is I don't state the domain first like that to make sure my answer works. All I do is I just solve the equation, and then I plug it back in and see, does that make it 0 or negative? Because if it does, we have to throw it away. Okay? So I think we better do a guided practice. I felt like that felt a little convoluted and confusing to you guys. So we'll do a little guided practice here. Let's do another one. This time I'd like us to go in the right order. So we want to state the domain. And we want to solve. Okay, so we'll call this guided practice 1. All right. Then you have to stand. I'm going to let you sit there. It's a special chair for my invisible friend. All right. So I went a little bit out of order last time. I solved first, and then I did the domain. So let's go ahead and start in order here this time. So I want to start by solving the domain. So kind of. So Nicholas, how do I find my domain?
For the first one?
Uh-huh.
So you're going to cross out...
So we're not going to cross anything out yet.
Right, that was wrong.
That, remember, I started backwards. I just want to find the domain.
Got it. So you're going to write x minus 5 is greater than 0.
Good. All right.
Mr. Bailey, is it always going to be greater than 0?
Is it always going to be greater than 0? What is it?
The argument?
Yes. Good. Not x, right? Sometimes x will be and sometimes x won't be. Condicker, so that's one of them, but what's the other one what's the other inequality I need to write? Oh, Condicker's out of commission right now. Let's do Giovanni Ramirez. What's the other one I need to write?
2x plus 3
Uh-huh.
is greater than 0.
Good. All right. So you have to do both, right? You have to do one for this one and this one. All right. Let's continue. So why don't you guys go ahead and solve those, see what you guys get. Giovanni Perez, what did you get for this one here, bud? Okay, good. So this means that for an answer on this problem to work, x has to be greater than 5. Okay? Let's go ahead and take a look at the next one here. Braden, what did you get for this one?
X needs to be greater than negative 3 halves.
Good. So it also has to be greater than negative 3 halves. So, do you guys agree that really all I need to know is this? Because if it's greater than 5, it's also greater than that, right? So that's all that really matters. But we could still do both, because you really don't know which one's the more stringent one until you actually do both. Okay, so now we're going to start solving it. So that's the end of part A. I know that x has to be greater than 5, and just by way of default, greater than negative 3 halves. Yeah?
Wait, so if you got like 3, would that be wrong because it's not greater than 5?
You're right, yeah. So he's asking a good question. He said, what if you got 3? Because 3 is bigger than this, right? So that would work for this logarithm, correct? But is 3 bigger than 5? It won't work for this. And since we're solving an equation that involves both logs, it has to be something that works for both. Does that make sense? So really, it's okay to write both of these. But I hope you guys are seeing this is kind of unnecessary, because if it's bigger than 5, it's already bigger than the other. Okay? All right, so let's continue here. So Amanda D, I want to start solving this for part B. What was the first thing I did when I started solving this? Yeah. Now, the only reason I'm allowed to do that, because you have a log on both sides, right? And they're the same. So, don't do that all the time. We're going to see problems later today where there's only a log on one side. You can't just kill the log like that, okay? But in this case, we can. All right, and so from here, we're going to go ahead and solve it. So I'm going to let you guys go ahead and solve it. Go ahead. Wait a few moments. Okay, so let's talk to Edward. Edward, what'd you get? I agree with you. Any questions? So you got negative 8. So now we have to make sure that that answer is allowed. So I want you guys to look. We got x equals negative 8. Does that work? The answer is no, right? So we're going to cross that off and put no solution. Now, I actually wanted this one to work. I just didn't think real hard about what I was writing. I was hoping it would.
No solution because x is supposed to be greater than 5.
Let's write that. Let's write that. Since our answer is not greater than 5, we're going to throw it out and say no solution. Now, once again, though, I don't usually check my answers like this, like Amber was saying. I don't really ever start by doing my domains. It's like extra work. But I think it's a good thing to learn and be aware of. What I do is I just take my answer and I plug it in. If I do negative 8, take away negative 5, is that going to work? No, you're going to get negative 13. You can't have negatives in there. You can't have zeros or negatives. Same thing over here. If you plug in negative 8 over here, you're going to get negative there as well. So that's no good. Okay? So, now, the reason why I wanted this to work is because, really, it's pretty rare it doesn't work. Usually, with logarithms, almost every time, they always work. It's like, but there's really 2 times when they can fail. One is when you have equations like this, they can fail. But for the equation I'll show you a little bit later, they don't give you no solution almost ever. So it's pretty rare, but there it is. So we practiced. Now I want you guys to do one on your own, okay? From beginning to end, I would like you to do both things. I want you to state the domain, and then I would also like you to solve it. All right, where was I? Don't let the ln scare you. It doesn't matter. There you go. All right, so go ahead. State the domain and solve for x, and make sure that your answer is allowed. If it's not, throw it out and say no solution. So, Kalani, what did you get for your domains? Good. And on both of these examples, you know, the arrow stays the same. The inequality is going to stay the same. But don't forget, if you ever end up dividing by a negative, you will have to flip it. It reverses things, okay? So long as my answer is greater than negative 2 and greater than 3 halves, then we're good. So it has to be both those. So which one of these inequalities doesn't really matter to us? Yeah, because if it's bigger than this one, it will automatically be bigger than that one. So that one kind of doesn't really matter to us at this point. But you can write both. It wouldn't be wrong. Let's go ahead and move on here. So Melanie, what did you get for x? 5. 5 is correct, right? So you drop the log off both sides, subtract 2, add 6, divide, and you're going to get 5. And so the next thing we got to ask is, Sam, is that answer allowed, or am I going to cross it off and say no solution? It is allowed because it's bigger than 3/2. So we're good. Or the other way you could check is just plug it into both and see if you get a negative number or a 0. And 5 won't make either one of those arguments become 0 or negative, so it's a good answer. Okay. All right, so that's kind of the gist of it there. We get out here at 8:22, so we got time to do one more topic, and that'll probably be where we stop for the day. So before we progress, write this really quick. You don't need to write this. You guys can just watch. Do you guys agree with that statement there? Okay, I just want to make sure you're good with that. I'm going somewhere with this, I promise. Now, oops, that's not what I wanted to do. What if I make that number a power of 5 and this number a power of 5 as well? Are the sides still equal? Right? Because I did the same thing on both sides. I did something kind of weird though, right? Never seen that before. I made these numbers, which are equal, the power of the same number, right? So, for instance, if I told you guys this was true, if I told you that, well, let's make it 11. If I told you that x equals 11, would you guys feel comfortable with me telling you that, therefore, this is also true? Right? Because if x equals 11, then those sides are exactly the same. All right, that's what we call exponentiating, okay? So it's like anything else in algebra where, you know, to solve for x, right, you add to both sides or subtract or multiply, right? Well, same thing with this is you can exponentiate both sides and you're good. We also did something else new with equations today. If you have a log on both sides, you can kill it, okay? So, now, do you guys also remember this? You may want to write this one down because this part it's review, but we haven't used that very much. But do you guys remember what that equals? No? It equals that. Something we saw a while ago, a couple of classes ago. We don't really use it very much, but we're going to use it a whole lot now. This and this are opposites, and they kind of cancel each other out, basically, right? So you don't need to cross things off like that. But if you didn't remember that and you feel like you should have that in your notes, then you might want to write it down. Okay? All right, so what we're going to do now is we're going to solve some log equations. We're going to start easy, and we'll move our way up to more challenging ones. So, now I'm going to put a problem up here, and if I were to ask you guys to solve this, you probably would be able to do it without me telling you anything. Some of you would probably be able to do that, right? Just based on the things we've learned. But I don't want you to go the route that you would be going to accomplish that. I want to take you down a new path to solve this, because this new direction I'm going to take you is how you're going to solve most of the log problems we're doing. So, but a lot of you guys could probably get the answer. Like, does anybody know? 64. It's 64. But magic. He practices witchcraft or something. I don't know what he does. All right, no, but here's what we're going to do, okay? we're going to, this is the main thing, is we're going to exponentiate both sides. And what that's going to do is it's going to cancel the log out. So you remember this slide here, right? This, if you have a here and a here, they cancel each other out, and you're just left with this, right? Okay, so that's the trick we're going to use. What base does this log have? 4. So check this out. I'm going to exponentiate both sides with a base of 4. This is going to become a power over here. And this is going to become a power over here. And that doesn't make those equations unequal. You're right. You're right. But trust me, this is a different way of thinking about the problem, and it will help with future ones. I think it will. That's my opinion. All right. So make sure you highlight this. And this is called exponentiating both sides. Exponentiate both sides. There's some of your math vocabulary. Exponentiate both sides. Okay. All right, so check it out. What happens over here now? They cancel out, which leaves me with this, which is 64. Okay? Huh? I know it is, but trust me, it will help. Maybe, I don't know. If you want to try to go a different path, it might not be bad. It might work. So. But you're right. It is more of writing. I agree with you. All right. So here's the thing. So how do you remember before we solved the equation and we had logs on both sides? We just canceled it, right? That was allowed because there was a log on both sides. But for this equation, do I have a log on both sides? So now here's our question. How do you get rid of the log? You exponentiate both sides. That's it. Okay? All right, so I want to throw one of these at you guys real quick here. Log base 4 of n. All right, so I want you guys to go ahead and solve that for me, okay? Yep, what? You what? Were you confused? Okay. Okay. Let's try Haley. What'd you get, Haley? Don't be afraid. Just tell me what you got. Be brave. Don't look at Steve. Look right here. What'd you get? Nothing. Oh, that's a lie, Haley. I'm gonna come look at your paper.
It's actually not a lie.
Why not? Did you not know what to do? It's okay to say yes. I need to know that. You just didn't know what to do. Okay, I just want to make sure it wasn't like because you were texting or something. That's a whole different situation. Xana, what'd you get? Okay, we need to do more. Don't pack up. Don't pack up. Here we go. What do I need to do? We need to exponentiate both sides. That means we need to make both sides a power of what base? Don't pack up. I hear way too much shuffling. Don't pack up. You guys got to get this. Don't walk out of here without this. Because if you don't know how to do this, you're screwed tomorrow. That's because we're doing this all day tomorrow. All right? So, now what do we do? Okay. Now at this point, if you got that far, then I'm pretty happy, but I do want to keep going. So, Quinn, what do we do with negative exponents? Which would be? Okay, don't pack up. You got 2 minutes, and you guys can do this in 2 minutes. I want to throw one more at you, yes? Oh, you could write it as a decimal if you like, or a fraction. Either way works. Thank you, Gabriel. All right, one more. Don't you pack up on me. You could do it in 1 minute. It's that chill. Don't you pack up on me now. Yeah. Am I doing this right?
No. Okay, 2 minutes.
Show your work too. No simple answers. I just want you to see. I want to see your work.